My name is Laujuni and my matrix number is A176653. Now I will present about our project introduction and objective. Shaft has a circular cross-section and is used to transmit power and may be used to transfer rotation or torque. However, for drive shaft, it is used to connect other components of a drivetrain that cannot be connected directly because of distance. While for gear is a rotating circular machine part having cut T which merge with another two parts to transmit torque and speed. Now I will talk about the purpose of drive shaft. Drive shaft provides a smooth, uninterrupted flow of power to the axle, and it is used to transfer this torque produced from the engine. Now I will talk about the objective of our design project. Our objective is to design a drive shaft for a car. Secondly, our project is used to carry out the stress analysis and safety factor on the design drive shaft.
Next, methodology part. The mathematical analysis consider all of the variables such as maximum deflection, maximum von Mises stress, maximum shear stress, and so on. All of the calculations are done by hand in it. To avoid whirling vibration, the torque transmission capability of the drive shaft should be larger than 3,500 Nm, and the fundamental bending natural frequency of the drive shaft should be greater than 6,500 revolutions per minute. Next, design tool. Modeling in this project was done with the Autodesk Inventor 2022 software, which is capable of producing exact 2D and 3D model and can generate 3D parts, assemblies, and 2D drawings. Again, the Inventor was used for simulation. 3D model was created, and the drive shaft was connected at both ends. The shaft rotated at consistent speed about the longitudinal axis.
We choose stainless steel as the material for the shaft after considering a variety of material. This is due to various factors, the most important of which is that stainless steel has a yield strength of up to 689 MPa, which is far greater than the required yield strength of a shaft, which is 206 MPa. The drive shaft is designed using the Inventor Professional 2022 software. This is the shaft 3-dimensional drawing as well as the detailed drawing. The drive shaft is made to be 263 mm long, which is the standard length for drive shaft. The diameter of the shaft at its widest point is 40 mm and the estimate drive shaft weight is 2.1 kg. This table summarizes the result of the static analysis simulation performed to the shaft. For this simulation, a load of 50,000 N is applied to the shaft to estimate the von Mises stress. According to this table, the maximum von Mises stress applied to the shaft is 4.57 MPa. Since the yield strength of stainless steel is 689 MPa, which much greater than von Mises stress, this demonstrates that the shaft will not break when a 50,000 N load is applied to it.
Now the discussion part. In the discussion, we will talk about the safety factor. The safety factor, also known as the factor of safety, expresses how much stronger a system is that need to be for intended load. Because composite testing is practical on many projects such as bridge and building, safety factor are frequently calculated using detailed analysis, but the structural ability to carry a load must be determined to reasonable. Failure to meet the required safety factor can lead to catastrophic failure. A high safety factor is required in this design to ensure unknown failure. Here are the calculations that we get from using a safety factor. Here are the calculation of the shaft. As you can see, here are the parameters that we get from this design. First, calculate the torque of the shaft. Here are the calculation. Module of the rigidity. By using this formula. Next is polar moment of inertia. Next is how we calculate angle of twist of this design. We also can get the power from this design by using those formula. The shear stress can be calculated by using this calculation. Lastly, the maximum shear stress that we obtain from this design.
Last part is conclusion. Through this project, we can conclude that the width and stress caused by composite material shafts are lower than those induced by conventional steel shafts. So, to avoid sudden failure, most drive shafts are manufactured of composite steel with the aid of high-grade steel. In addition, composite materials are employed in some cases to achieve unique features.